A developer is considering two projects. The first one has a capital cost of $100,000 and an annual income of $20,000. The second has a capital cost of $30,000 and an annual income of $11,000. Both projects will generate income for 25 years. Compare these two projects using net present value analysis using discount rates of both 8% and 15%. So we're comparing two projects. One project which is expensive, costing $100,000, but gives us an income of $20,000. Another project which doesn't cost as much, only $30,000, but also gives us a much smaller income. Now, both projects are going to last 25 years, and we're going to use discount rates of 8% and 15%. So let's start project 1 with the discount rate of 8%. So the net present value for project 1 at 8%, well, first of all, we've got the capital cost. So this is already a present value, so that simply becomes minus $100,000. Then we have to add our income. So that's going to be plus $20,000 times the conversion factor, which in this case is going to be 1.08, because we're working on 8% first, to the power of 25, because the project has a life of 25 years, minus 1, all divided by 0.08 times 1.08 to the power of 25 without the minus 1. So this gives us minus 100,000 plus $213,496, which gives us a grand total of $113,496. Okay, so that was project 1 at 8%. What about project 2 at 8%? Well, in this case, our capital cost is smaller. It's only $30,000. Plus, we have the income of the $11,000 times its conversion factor, which is 1.08 times to the power of 25 minus 1, all divided by 0.08 times 1.08 to the power of 25, which is equal to minus 30,000 plus 17,422. So this is equal to a grand total of $87,423. So what you can see is that project 1 is better than project 2. That's if we use 8%. Now let's look at the net present value if we use 15%. So we get a net present value for project 1 at 15%. Well, we've got the same capital cost, so it's going to be minus 100,000 plus same annual income, 20,000 times, but this time we're changing our discount rate. So it's going to be 1.15 to the power of 25 minus 1, all divided by 0.15 times 1.15 to the power of 25, which gives us minus 100,000 plus 129,283, which gives us a grand total of 29,283. Now, this number here is smaller than that number there. In fact, we expected that to happen because we knew when we used the bigger discount factor, the bigger discount rate, it was going to make our future benefits worth less. So it's not surprising that this ends up being less than this. What's interesting is when we start comparing this to the result we're going to get for project 2. So let's do that. So the net present value for project 2 at 15% is equal to minus 30,000 plus 11,000 for our annual income, but this time we're going to use 15%, so 1.15 to the power of 25 minus 1, all divided by 0.15 times 1.15 to the power of 25, which is equal to minus 30,000 plus $71,106. You'll notice that the benefits, because of the larger discount rate, have become smaller again. And so this ends up being 41,100 So this ends up being $41,106. Now, the important thing to notice is when we used 8%, we had a better net present value for project 1, was better than project 2. But when we used 15%, the net present value for project 2 was larger than for project 1. So what you can see is that by changing our discount rate, we've changed which project is better.